Hey, are you gonna get this pig out of the way?
Well, that's rude. I mean, I've gained some weight, but you don't have to call me a pig.
No, I mean this pig here, standing right in the middle of our fight.
Oh, there's an actual pig in between us. Okay.
Yeah, well, get rid of it.
Why don't you move it?
This is your pig, so you should get it out of the way.
Well, it's not my pig.
Well, it was over in the evil lair next to Mr. Freeze, and Mr. Freeze is your ally, so obviously the pig is your ally too.
Oh. Well, I don't know. Maybe he was one of Lord Business's prisoner.
Oh, so this isn't your pig?
No, look, my team is predominantly bears. Bears. What am I going to do? Put someone on the team who's going to be a cross between a pig and a bear? That just sounds fruity, actually.
Alright, then pig, you can come be on our team.
Wait. No.
Well, you just talked about how it wouldn't make sense to have a cross between a pig and a bear. So it wouldn't make any sense to put him on your team.
Well, that was before I knew you wanted him. Now I'm perfectly fine with him being on the bear team. Pig, bear, sounds delicious. Come on, you can join our team.
Then I guess there's only one way we settle this. Here, piggy.
Come here, piggy. Come here, piggy. Sweet piggy. Piggy.
No, come here, pig. Come on, pig.
Sweet piggy. Come here, piggy. Come here. Alright, he's not responding to this. We're going to have to do something different.
You and I have a rock, paper, scissors battle. To the death.
No. I don't have nearly enough rocks for that. You and I are going to have a math battle.
Sounds nerdy.
That's right. That's why you're scared of it.
I'm not afraid of you. Bring it on.
Here, scooch back, pig. I happen to have with me 2 copies of the 8th grade release STAAR test. There's one for you. Pick your problem.
Number 1.
What? No, that's boring. You can't pick number 1.
You told me I could pick any number.
Well, that was before I knew you were going to pick something boring.
Okay. Number 2.
Number 2 is even worse. Even numbers are more boring than odd numbers.
3.
Fine. For the sake of this battle happening today, number 3. All right, what does your number 3 say? I'm going to find a problem on my test similar to number 3. You and I are going to solve. And then whichever one of us solves it better gets to keep the pig.
All right, you're on.
Okay, so we can see here, question 17. The table shows the completion times of 4 runners in a race. So I got Joe, Ellen, Steve, Patty, and they're all pretty close. So this is how many seconds it took them to finish the race. So conceptually, don't forget, if you finish a race in 1 second, you're like super fast. Whereas if it takes you 72 seconds to finish that same race, you're significantly less fast. So the bigger numbers here are slower. So I'm going to make a note over here. Big equals slow. And that's going to matter because down here, which list shows the runner in order of their completion times from fastest to slowest, I want the littlest numbers over here on the left. The fastest people should be the littlest numbers. And then somebody who's got a little number but bigger than the littlest number. And then somebody who's got a fairly big number. And then somebody who's got the biggest, giantest number. So I want to make sure that they're listed from smallest number to biggest number, because in a race, the smallest numbers win. Those are faster. And so what I have to do is I have to be able to compare all these fractions and decimals, but they're fractions and decimals. Like, it'd be a pain enough to just try to compare 1/2 and 2/5. Well, unless you're me and you just did it in your head automatically. But basically, what we want to be able to do is convert all these into either fractions or decimals. And this one, the way it's set up is kind of nice. If you look at a decimal, then you can name the place values. So we're used to seeing 1's place, 10's place. You know, if you have a 5 and then a 1, it's not 51, it's 51. And then hundreds, and then thousands, and keep going that way. But at the decimal, you have what I like to call the butterfly. The number 1 is like the body of a butterfly. It's just a long stick. That's the butterfly. And a butterfly's wings are always symmetrical. So if you have 10's here next to the body, then this first place is going to be symmetrical. The only difference is, because it's after the decimal, it's tenths. And then if you go one beyond that, again, because a butterfly is symmetrical, the hundreds place is going to match with the hundredths place. So it's not like a butterfly where it's perfectly symmetrical. Over on the right side, past the decimal, you do have to add the th there because it's parts of. But that's a nice easy way to name the decimals. So here, this is 12 and 8/10, which right away you could see I could write as 12 and 8/10, because when I say 8/10, there's an 8 in that 10th spot, that I'm literally saying the fraction 8/10. And then the fraction here, 12 and 2/5. The fraction here, 12 and 9. Be careful, the 9 doesn't stop in the 10ths place. It stops in the hundredths place. So this is 12 and 9 hundredths. And then 12 and a half. And so I can easily turn all those into fractions. Now, they're still a pain to compare until they all equal the same, but 100 is a nice easy number, and so if we can just change them all to match 100, we can just compare straight down. So 10's easy. 10 times 10 is 100, but I'm not just changing the bottom. That would change the fraction. I'm going to multiply the whole fraction by 1. Now, if you didn't think that looked like 1, just remember, if I have something cut into 10 pieces, and I eat all 10 of the pieces, I ate the whole thing. So any fraction that's got the same numerator and denominator is 1. Well, now this is perfectly okay, because I can multiply anything by 1. That's just going to be itself. 2 times 1 is 2. 7 times 1 is 7. A cute little butterfly times 1 is a cute little butterfly. So I'm not changing this number. I'm not making it a different answer. It's going to be the same exact thing. It's just going to look fancier. So now 10 times 10 is 100. 10 times 8 is 80. And already I can compare Patty's 80 hundredths to Ellen's 9 hundredths. Ellen was definitely faster than Patty because Patty had a bigger, aka slower number. And I just keep doing this with all these others. 2, well, that's half of 100. No. I want it to be 100. So half of 100 is 50. There we go. So if I multiply 2 by 50, that'll equal 100 on the bottom. And then my one rule says I can't just multiply by 50 randomly, but I can multiply by this special version of 1. 2 times 50 is 100. That's what I wanted on the bottom. And then 1 times 50 is 50. And so Joe here, with his 50 hundredths, is smaller than Patty, so he's faster than Patty, but he's also bigger than 9/100ths, so Ellen is faster than Joe, who's faster than Patty. So far, Ellen, Joe, Patty, Ellen, Joe, Patty. Those could both work. Patty is definitely bigger than Joe and Ellen, so Patty needs to be after them. So A and D are already out. And now we just have to see, does Steve fit in between Joe and Patty or between Ellen and Joe? So Steve here with a 5 on the bottom. I'm going to multiply that by 5 times 20 would give me 100. So 20 over 20. Remember, I can only multiply by 1. I'm just picking the special version of 1 that will give me the answer. It'll give me the look I want. It's the same answer no matter how it looks. We just want it to look like it has 100 on the bottom. So 5 times 20 is 100. 2 times 20 is 40. And so he's not even close to Ellen. Ellen's below 10. Everybody else is multiples of 10. But he is the fastest, aka smallest of the other ones. So it should go from Ellen to Steve and then to Joe. So we have C as our answer here. And there we go. Solved, and almost certainly solved much better than Batman.
Yeah, that's much better. I mean, as long as you like listening to some bear fanatic yabber on for 20 minutes. Here, kids, here's a much quicker way to do it. First of all, you read the problem to yourself, so you don't have to listen to that guy talk. Then, once you realize we're just trying to get these from greatest to least, you get out your calculator.
What, a calculator? That's cheating.
No, in the 8th grade STAAR test, you could totally use a calculator. Look it up.
Well, yeah, I mean, but you don't have to.
Yeah, and I don't have to use the Bat computer to solve all the Riddler's crimes. But I do, because I use my tools. Because I'm Batman.
Well, this has got to be cheating.
No, it's just better than your way. Anyway, kids, when you click on mode, you don't want it to float, because we got to compare a bunch of things. So put 9 here. That'll make sure it shows all the decimal places, all the way up to 9. So on your calculator, you come down to float, and then over, all the way to 9. Or just go left, too, because that's much easier. Then hit enter on your calculators. Now, no matter what I put in here, it'll give me 9 places after the decimal, which will make it super easy to compare. So, second, quit to get back to the main screen, and then just type in your fractions. 3 divided by 25. Not 255. So it's 0.12 and then a bunch of zeros. Next up, square root of 3 divided by 11. Second, square root 3. And I'm done with the square root. So I come back outside, divide that by 11. Then 9 divided by 100. And then pi, which is going to be the second key. And the little pi here on the caret button, divided by 24. And now I have all 4 of my fractions. So I can see the greatest one is the one that has the biggest number first, but there's a 3-way tie. So the next biggest number It's gotta be here. Square root of 3 over 11. A and C are already out. And then the next biggest number is 0.13. So pi over 24 is next. The answer is B for Batman.
All right, kids, so there you go. Now, normally I know the like and unlike buttons are for if you like or dislike the video, but this week you're going to use these buttons right here.
No, to the right.
Oh, right here?
No, they're right.
Over here?
This is already off the rails. The buttons are over here. Right down here.
Oh, okay. You're going to use the buttons right here. If you thought I did a better job showing you how to solve math problems, then give this video a big thumbs up. And if you thought Batman's totally cheating way was better, then give this video a big thumbs down.
How come you get to be thumbs up?
Because I typed the descriptions.
Well, you could go back and retype them.
I don't have time for that.
Yeah, but you do have thumbs for that.
Oh, that's not even fair.
All right, kids, thumbs up for Bat, thumbs down for Bear.
What? No. No, no, that is not how we're doing this. No,
Batman out.